Welcome everybody to the North Carolina Fossil Club May meeting. We're so happy that you all could be here. I'm Diane Willis, for those of you who have not ever seen me before, and I haven't seen you. It's nice to get some of the people who are farther afield normally and aren't able to come to our Raleigh meetings. But I'd like to thank Bruce MacFadden and his graduate students for providing this Zoom platform for our meeting. We're really grateful to you, Bruce, for that, and as well as doing the program. So I'm going to introduce our program, which is Belgrade Mammals and the Fossil Project. Our speaker is Dr. Bruce MacFadden from the University of Florida. He's the curator of vertebrate paleontology and founding director of the Thompson Earth Systems Institute. He's been on the faculty since 1977. He's the author of 200 peer-reviewed publications and a recent book called Broader Impacts of Science on Society. It's published by the Cambridge University Press in 2019, so you might want to check that out. During his career, he has done extensive field work in North and South America. His area of expertise is fossil mammals, and in particular, horses. He was the lead scientist on the Fossil Project and is now very interested in bringing science into the K-12 public schools, and he's interested in developing citizen science collaborations that promote a better understanding and appreciation of fossils, the history of life on Earth, and the science of paleontology. Bruce currently serves as the president of the Paleontological Society, which I've mentioned before is something that amateurs can join also for not very much money, and it's worthwhile because you get access to their library as well. Well, publications, I'll say. So with no further ado, I'm going to mention a couple of rules. As Bruce begins to speak, everyone will be muted by Jeanette, and while Bruce and the program with Victor and Jeanette, his graduate students, are going to, while they're doing the program, nobody will speak. When it's time for the Q&A, they will say so, and then Jeanette can unmute everybody, and you can mute yourself until you want to ask a question or show a specimen or something like that. I hope everybody knows how to unmute themselves and mute themselves. So, no further ado, Bruce, it's all yours.
Thanks, Diane, and thanks for your patience with the Zoom platform. I hope it works well for you. And I know it's not as much fun as being face-to-face in a real meeting, but the benefit of Zoom is that if people are from further afield and can't, physically come to a meeting, they can join the meeting by Zoom. And I hope that this is something that you think might work for you in the future as well as needed. Yeah, so I want to introduce my graduate students. Let's see, Jeanette Pirlo is one of my PhD students in biology. She is our technical support person for this meeting. She'll be muting and unmuting and making sure that the Zoom platform works as well as it can. Dr. Victor Perez just recently successfully defended his doctoral dissertation, and he's now Dr. Perez. I mean, this is just last week, okay? So he's a newly minted PhD. I see Lee Cohn has a big smile on his face there. That's great. Victor is gonna moderate the chat. So if you have a question during my talk, we're not gonna stop and do Q&A in the middle of the talk. We'll hold all the questions until the end. And just, if you hover down at the bottom, for those of you who are new to Zoom, you just bring your cursor all the way to the bottom of the screen, and there in the middle is called chat. And that's just, you just type in a question that you want to have answered or a comment, and then Victor will moderate the various content or the question and answers on the chat. So with no further ado, let me see if I can share my screen and start my talk. Can everybody see my the first PowerPoint slide? Victor, everybody, thumbs up if you can see the PowerPoint. Excellent. So okay, I can get started then. Yeah, so I was going to talk primarily about land mammals, which is my specific interest, but I want Victor to talk about some of the discoveries, his work on the sharks, particularly the shark fossils that were collected 2 years ago at Belgrade. And then in general, an overlying theme of this project is the fossil project that many of you are aware of. And if you aren't aware of it, I hope you'll have a better understanding of the fossil project when I finish my talk. Okay, so for some reason, let me see here. There we go. So we've talked about the Zoom format. If any of you have fossils from Belgrade, or I can't see everybody's video, but if you've ever collected fossils from Belgrade, I'd be interested. Raise your hand and let's see if we can. Let's see if I can. Yeah, I'm just going through the entire. A lot of you have collected at Belgrade before, and that's great. Okay, so I want to provide an introduction, and let me go back to the original my screen. I'm there. Good. I want to talk about why Belgrade is important, a little bit about the introduction and the geology of Belgrade, and then I want to defer and let Victor and Jeanette talk about how they've been focusing on some of their work on Belgrade, and then how you can get involved through the myFOSSIL project, and then we'll do a wrap-up, questions, and open discussion. First, I want to thank some people. There are lots of people to thank, and I realize I should be thanking Julie Niederkorn as well as Sam Schmidt, because Sam sent us some fossils that they collected in the 2018 the campaign from 2 years ago. But in particular, people who've been involved both not just in Belgrade, but also in the fossil project for the 7 years that it was in existence. It ended last year in 2019, but the project still continues with the website and the applet that we developed. And overall, I'd like to thank Lee Cohn and Linda McCall for their active participation in the fossil project for the entire time. And since that time, I also want to highlight that you mentioned, Diane, the Paleontological Society that I'm president of. I'm also pleased to let, now Linda is waiting. We got to admit Linda, because she's supposed to, her hair, probably her ears are burning here. I wanted to let everybody in your club know that Linda has been, is part of the executive committee or the Council of Paleontological Society, and she's what's called the Paleontological Society Avocational Liaison, who represents amateur paleontologists and fossil clubs and individuals who are otherwise interested in paleontology, and she represents their interests to the Council of the Paleontological Society. So Linda, thank you for your participation. And then I should also recognize Dave Bohaska. Many of you know Dave Bohaska from the Smithsonian. He's also been involved in the Belgrade project. Diane, is the sound okay? Good, yeah, thumbs up is a great way to go. For some reason, my screen isn't advancing. Can you
just need to click on the screen?
Click on the screen? Got it, thank you. I was using on the, very good. So why do we study Belgrade? Well, I don't need to tell the club that Belgrade's important, but it's well known to the community on the East Coast, amateur fossil collectors, clubs, but also professional paleontologists, particularly if you're interested in the Cenozoic sequence, going back about 40 million years until the Pleistocene, just several tens of thousands of years ago. The Belgrade fossil quarry is a really important place in the eastern United States. The other thing is it's accessible. We all know that we have an increased problem with liability and fossil sites being closed down to public participation, but thank goodness Belgrade is still allowing folks to go in and collect fossils from that locality. The other thing is Belgrade is really, it's, as you all know, for those who've been there, it's really fun to collect at Belgrade. There's so many fossils there. It's really cool. There are invertebrates, there are sharks, and some of the ones that I am most interested in are the land mammals, which are exceedingly rare and therefore virtually unknown. And I hope that you'll have a better appreciation for the land mammals from Belgrade and why they're important by the end of this talk. So you likely all know that there's a really good geology report that's accessible to the, for the public about the stratigraphic succession of Eocene, Oligocene, and Miocene sediments in the Atlantic coastal plain of North Carolina. And this is open source. You can download this PDF for free if you want this report and read about the geologic background to the geology of this area in general, but also specifically to what's called locality 20, which is actually the Martin Marietta Belgrade mine. And you can get this report. The link to the report is on this page. So the stratigraphic sequence described in that report go back into the Cretaceous, as you can see in this chart on the right. But Belgrade, this is what's called a composite section, which pieces together sections of rocks in different localities in the coastal plain. And locality 20 is the Belgrade Quarry, and its stratigraphic sequence goes from the middle Oligocene river bend formation all the way to, in this illustration, the Croton formation, which is Pliocene. I should also tell you that there have been Pleistocene deposits or Pleistocene fossils that have been found from some overburden on top of the Pliocene locality, Pliocene sediments. So this is, locality 20 is Belgrade, and this is the stratigraphic sequence that's depicted or described in this report from the U.S. Geological Survey. And an outcrop of this section you can see from this mine, from Belgrade, you can see in the photo on the left. So why I'm interested in Belgrade is that fossils have been brought to light from the Belgrade, mostly from collectors like yourselves, that indicate that there's a time interval from the early Miocene where some very rare land mammals have been collected by folks from Belgrade, which are of particular interest to the types of fossil land mammals that I study as part of my specialty. In particular, I'm interested in fossil horses. Can you see my cursor when I move it on the screen, Jeanette? So I'm really interested, for example, in this tiny little tooth right here. This is in the Smithsonian collection. This is of a tiny horse called Archaeohippus, which is also found elsewhere in North America. Diane, the fragment of the tooth that you found, was it 2 years ago? Or was it last year? I can't remember whether it was in 18 or 19. It was when you were with us working those piles, you found a fragment of an animal that looked like a little deer. Well, it's an animal called Paratosauros, and these are some plaster replicas in the Smithsonian collection of some casts of Paratosauros from this locality. We have a rodent tooth here, a small carnivore tooth, and then a large pig-like animal that you can see here that's been found by various collectors over the years. Now, I should tell you that these are 1 in 1,000. For every 1,000 fossils that are collected from Belgrade, we might find one land mammal. So they're really, really rare, and that's why we don't, likely you've not you, Diane, but other folks, you likely have not collected these, or if you have, you may not have recognized them. They come from a very specific locality called the Belgrade Formation, where the blue arrow indicates it's of early Miocene age based on these fossils. And these early Miocene fossils from Belgrade are very similar to land mammals that we see in commonly encountered in the Western United States, like you can see in this diorama reconstruction from the old Smithsonian exhibits. This is a reconstruction of what life was like in North America about 20 million years ago. Okay. And this is, if you've been out to Agate Fossil Beds National Monument, the kinds of fossils that you see on display in this cool little visitor centers are the kinds of fossils that are being collected from Belgrade by folks doing field trips to those mines. And Belgrade, in terms of a big picture in North America, it helps to fill out our understanding of what life was like in Eastern North America on land about 20 million years ago. there are only 2 other fossil sites in all of eastern North America that have early Miocene land mammals, and added to that is now the Belgrade locality. The land mammals from Belgrade have not yet been described. That's something that we're working on. Coincidentally, I had a project collecting fossils along the Panama Canal for 8 years, which ended in 2000, well, ended about 2 or 3 years ago. And interestingly, the kinds of fossil mammals that we find in Belgrade are also similar to the kinds of fossils that we were finding along the Panama Canal. They're all the same age, about 20 million years old, early Miocene. Here's an example of what it was like to collect fossil mammals from literally right along the Panama Canal. These were 4 student interns of ours that were hired to collect fossils along the Panama Canal. And in the right-hand picture here, there's actually a scapula, the shoulder blade of a rhinoceros from the Panama Canal. And interestingly, Judy Niederkorn found, I think it was a toe bone, Julie, that of a rhinoceros that I think is a similar kind of animal to what we were also finding along the Panama Canal and also into Nebraska. And then this is a bear dog jaw on the right here from a block of sediment from the Panama Canal. I don't think we found a bear dog tooth yet from Belgrade, but it potentially could be found with future discoveries. Or if there's something in your basement or garage that you don't know that you could show us, maybe we could find a bear dog. So this is what life was like in Panama about 20 million years ago. It wasn't quite as dry as depicted in the Maternus mural from Nebraska. This was more tropical. And I would say that probably North Carolina, based on the mix of animals that we find from Belgrade, probably was more similar to a scene like this, more tropical, than to the drier reconstruction that we saw from the same age in Nebraska. Some of the fossils are highly diagnostic and tell us that they're early Miocene in age, and one of them is this pig-like animal called Daeodon, and I know that you know about this because there's actually descriptions of fossils like this in your very well illustrated, nicely done fossil book, talking about the land mammals from Belgrade. You actually mention specimens of this giant pig-like animal from Belgrade. That animal is highly diagnostic to early Miocene time in North America. So it's a very good index fossil for that time. And it helps us to zero in on the age of Belgrade and the land mammals from that locality. So the problem with most of the collections from Belgrade until recently is that when the miners scoop out the sediments, getting the aggregate they want for commercial production, they dump the piles into spoil. They dump the sediments that they're not using into spoil piles. And these spoil piles are all jumbled up. And sometimes you don't know whether you're collecting fossils that are of Oligocene age, Miocene age, or Pliocene age because everything is put in these piles and it's out of stratigraphic context. Okay? So that's been a major problem in the past. We don't know exactly where the fossils come from, but if they're the diagnostic kinds of animals like Daeodon, we know they have to have been from the early Miocene or lower Miocene Belgrade Formation in that stratigraphic column that I showed you, and also you can see right here. Sometimes you'll find some fossils that are diagnostic of the Belgrade Formation, like these giant clams in the lower right, and typically you might find some land mammals associated with these. But the point of all this is that until 2 years ago, all the land mammals were out of stratigraphic context when they were collected. Then came along an initiative thanks to Lee Cohn, who contacted the mine manager at Belgrade, Doug Fetzko, and working with me to describe the importance of the early Miocene land mammals, we identified the locality as being these sediments in the left here that you can see on this cliff. In this general area, this is generally the Belgrade Formation over here. So what the mine operator did, Doug, he said, we'll go over and get our heavy equipment, and then what they'll do is they'll dig out large chunks of this, so then you know exactly where those sediments came from. So So the fossils from those sediments will be of known stratigraphic context. That was really revolutionary and totally different from what we knew before. And actually, you can see these 5 piles here. These piles were made for us prior to a project that we were working on with Lee Cohn and other folks from his organization. And we've gone back now at least once to further collect these piles. But the cool thing about these piles is that unlike previous collections where you really didn't know where the sediments were taken from, these piles are all known in terms of their exact stratigraphic context. So any fossil collected from these piles are of early Miocene age from the Belgrade Formation. So that's a major leap forward. And again, thanks to Lee Cohn, who convinced Doug, although Doug was great, the plant manager, and really was very supportive in allowing this research project to go forward. Now, I've not been back there for over a year, and probably you've seen these piles since the time I've been there. It'd be interesting to see if you're still getting stuff from there, because right now those piles, I believe, are available to be dug. Okay? Certainly, if I were to go back or want to go back again, I'll want to zero in on those and see what's available, what's been winnowed out from rains, etc., and also the flooding that, as you know, that occurred in this mine, what it was, 1.5 years, 2 years ago. So after these piles were made available to us, thanks to Martin Marietta, we had this citizen science field trip to the locality with Lee's group and then students from the museum. And we intensively collected just these piles for about 5 or 6 hours. And then we surface collected, like the shark's teeth that you can see in the middle. And then people were screen washing, like you can see in the left. And then we brought back matrix of sand to look for tiny fossils. And in fact, the Schmidts themselves brought bags of matrix back, and they also sorted through the matrix looking for fossils, and then they sent those fossils to us. The cool thing about this is all the fossils from this endeavor, we know the exact stratigraphic, what we call provenience or position in the rock column, and we know that they're lower Miocene. And Diane, this is where you found your Paratosauros half tooth, and if we had access to the CAT scanner, Jeanette would have actually scanned that, so we could have shown it, and you could have proudly, we could have had it displayed, and we could proudly say that you collected this for us. But we've not been able to get back to work for several months, and we hope to get a scan of that for you in the future and put it online. So thank you for your contributions. Thank you, Julie Niederkorn, for your contributions. The Schmidts, thank you for your contributions. And everyone else who's taken an interest in the importance of Belgrade in terms of not just the science of paleontology, but also community partnerships and community involvement in doing science together, the amateurs and the professionals and the fossil clubs. Okay, there we are. So Diane, here's an illustration of the kind of deer-like animal, a reconstruction of the deer-like animal that you collected a half tooth of, called Paratosauros. And prior to what's been found now, that some other teeth have been found from Belgrade, but prior to the discoveries from Belgrade, you can see that Paratosauros only was known from Panama up into the Texas area and into Nebraska, based on the red. But now your discoveries and the previous discoveries, like that white specimen in the Smithsonian, extend the range of Paratosauros into eastern North America during the early Miocene. Okay. All right. So I could talk about rhinoceroses. I could talk about horses, but I'd rather defer to my students now. And then really what I'd rather conclude with is more of an open discussion about what has your club done at Belgrade? What are you planning to do in the future? And how might we be able to work together to advance the science of paleontology based on the kinds of fossils that I'm particularly interested in from Belgrade? So I am now going to defer, I'll mute my microphone. I'm going to defer to my first student, Victor, who's going to talk about the sharks that he has analyzed with one of his undergraduate students that he's mentored from specifically the 2018 fossil collection from those 5 piles of rocks from which we know exactly where they came from the Belgrade Formation. So Victor, unmute your microphone and take it away, please.
Got it. And just get a thumbs up if you can hear me. All right, great. So thank you, Bruce, for inserting that doctor into there. But yeah, so I'm going to talk to you about kind of an overview of what we found during the 2018 field season. So as Bruce mentioned, we did go back in 2019 and collect more, but we haven't finished cataloging all that, particularly with our own access to our museum at this time. But what you can see is that from 2018, we have cataloged over 2,000 specimens, 2,753 catalog specimens. And these do not include the marine mammals, because the marine mammals, we made an agreement, those would be curated at the Smithsonian with Dave Bohaska. So breaking down what we have found from 2018, it is largely dominated by Chondrichthyes, which are our sharks and rays. So what I tend to study are the sharks and rays. These account for about 87% of the fossils we collected. Next is the Osteichthyes. These are fish that have a bony skeleton rather than the cartilaginous skeleton of sharks and rays. And those account for about 12% of the fauna. These are going to include things like goosefish, drumfish, porcupine fish, burrfish, things like that. Then we have reptiles, which represent less than 1%, but we do have crocodiles, turtles, and 1 snake vertebra that was found in 2018. And then finally, we have our mammals, which again are going to be mostly marine. So things like whales and dolphins, and we have 1 or 2 fossils of manatee relatives called dugongs, and then those very rare terrestrial mammals that Bruce has mentioned. So these are things that were collected by people in the field, surface collecting and sifting, but also from that material that we brought back to our lab and screen washed for the micro material. So from this general fauna, we can already say that we're in some kind of marine environment. But if we dig a little bit deeper into exactly what species we have, we may be able to narrow down that environmental context. So Bruce, if you could just click to advance to the next slide. Thank you. So as I mentioned, what I particularly focus on is the class Chondrichthyes. So the undergraduate student that Bruce mentioned, Fauve Wilson, she spent a lot of time working with me over the last 1.5 years, 2 years or so, working on the Belgrade material. She has since transferred to Eckerd College in Florida, so she hasn't been able to work with us as much, but she did get a lot done while she was here. So among those Chondrichthyan fossils, we had 22 different species we recognized from the 2018 field season. 14 of those species were sharks, mostly coming from the order Carolina Early Miocene. So there's 7 different species. These are going to include things like our requiem sharks, tiger sharks, hammerheads, and sharp-nosed sharks. And if we look at number of specimens, those account for more than 50% of the total specimens we've been finding, our carchariniform sharks. We also find a lot of lamniform sharks, which are going to be mostly sand tiger sharks, but we also get the ancestor of Megalodon, or Carchalys chubatensis, and thresher sharks, and a few others. But in terms of their relative abundance, they're probably about 12%, I think, of the Chondrichthyan fauna. And then finally, we have erectolobiformes for the sharks, which are going to be nurse sharks, and those represent a very small portion of our overall fauna. Then we have the rays, which are mostly represented by myliobatiformes, those dental plates that I'm sure probably every single person here has found. Those account for a significant portion of what we're finding and are represented by at least 5 different species. These are going to be eagle rays, spotted eagle rays, cownose rays, and whiptail stingrays mostly. And then we have rhinopristiformes, which are going to be our sawfish, Anoxipristis, and our guitarfish, which are represented by 2 genera, Rhynchobatus and Rhinobatus. So we did find all of these during the 2018. However, I will mention in 2019, we did find an additional order, which was Hexanchiformes. The 6-gill shark, Nodorhynchus, was found, which we did not find in 2018. So we're still finding some new things, and we probably will continue to find new things as we finish cataloging the material from 2019. So with that quick summary, I'm going to transfer it over to Jeanette to tell you a little bit more about myFOSSIL and the digitization process.
Thanks, Victor. And Bruce, if you could advance the slide, please. So I want to talk a little bit about how we take the, can you guys hear me okay? Okay. How we take the fossils that you guys find and essentially put them to research. So one of the big things that we believe in at the lab is, instead of us asking you to give us your fossils, we recognize that the process of finding and going out and collecting, you create a connection with the fossil. And a lot of times that connection is difficult to, I don't want to say sever, but essentially to give up to a museum because you found that fossil. And so one of the big things that we have going on at the lab with Bruce is, instead of us requesting you to donate your fossil, which of course we are always open if you guys want to donate a fossil, but instead we would rather borrow the fossil, CT scan it, and make an exact replica of that fossil, and then give it back to you whenever you're ready to donate that fossil, either to us at the museum in Florida or whichever museum you'd like to donate it to. So to do that, I just want to go over the trajectory of how we take your fossil and digitize it, or make a digital copy and bring it back into the museum, and then send it back to you. So this will be the small life history of the Anthracotherium tooth that Bradley Dixon found, I want to say probably 2016-ish, in the last few years or so. This was found at Belgrade, and as you can see, this is the original picture. The tooth was in several pieces. So essentially, the tooth is first collected in the field, and you as the collector might do some preparation on it. Either you wash it, you might glue some pieces back together, and you contact us at the museum and either send us pictures or send us or you see us at the Aurora Fossil Festival or something, so that we can ID the fossil. And if we decide that it's one of those mammal fossils from the Belgrade Formation, we would fill out some paperwork showing that you've loaned us the fossil, so that we can we have a paper trail of where that fossil is at all times. And then that fossil comes back to the museum with us, and it might get a little bit more prep work so that we can put it back together like we did with this Anthracotherium tooth. Our fossil preparator did a magnificent job, which you'll see in a few more slides. And Bruce, if you could advance, please. Afterward, once everything is put back together as best as possible, we pack the fossil for CT scanning. So the picture on the far left is a picture of the actual tube that CT scans, that sends out multiple X-rays. And so a CT scanner is just taking multiple X-rays in tiny little slices along the fossil. And the middle picture shows you, and these are Julie's fossils that she let us borrow, I want to say 2017, 2018. You can see that they are just a single X-ray, and we're talking about thousands of scans at a time. So it's taking, the fossil is rotating within a base, and the CT scanner is just hitting it with X-rays, and eventually we convert those multiple scans into a 3D volume, which you see here on the right-hand side. This is a safe method for digitizing fossils. Nothing happens to the fossil within the scanner. It's just like getting a X-ray done at a dental X-ray or an X-ray at the doctor. And this takes about an hour or so to scan a fossil. So depending on the size of the fossils, we can put several in there and maximize our time. But we have this wonderful CT machine on campus. Not that we have access to it right now, but we do have access to it throughout the year, as well as the digitizing software that lets us recreate the volumes. So once we have the volumes, Bruce, if you could advance the slide, please. We can send those original fossils back to the owner so that we don't have them still at the lab. We can send them back to the owner because now we have this perfect copy of the fossil. And you can see in the video that's playing, this is the 3D file that is available to download and print from the myFOSSIL website. And you can see everything. You can see the spongy tissue in the jaw here. You can see where there are pieces missing. You can see the holes. Those are not holes from the scanning. Those are actually the holes from the tooth itself. And you can see in the bottom left picture here, this little, I don't think you can see my cursor, but Bruce, if you can show that little hole in the bottom left part of the tooth, it creates everything perfectly, and it takes everything perfectly in that scan. So now we can send those fossils back and we can continue doing our identification at the lab without having to hold on to your fossil. We clean up those files. That takes a little bit of time depending on how much background noise there is with the CT scan, but you get these perfect replicas and we get those perfect files then for printing. And I think we sent out a couple of these prints back to Bradley when we sent these files, when we sent the original fossil back. If we move forward, final step is the actual research. So by now we've photographed the original file, the original fossil, excuse me, and we also have that digital file. So now we can do our identification work and describe the fossil from there, and we can make those files publicly available for other researchers to use, as well as people at home that don't normally would not normally be doing research on the fossils, but maybe want a copy of the file, people like at clubs or school groups, that sort of thing. And we can compare those with other species that are, or other collection specimens to do a better identification. And you can see down here, the bottom-most picture is a reconstruction of what a pig-like Anthracothere would have looked like. And they had these really robust teeth, which this fossil was in pretty good condition, I would say. And with that, I think I am ready to switch it over to Bruce.
Thanks, Jeanette. Good job, Victor. Good job, Jeanette. So the cool thing about the Anthracothere is, like the Daeodon, this is highly diagnostic to as a key index fossil to time. This particular genus of Anthracothere is only known elsewhere in North America in the early Miocene, like you find at places in Nebraska. So finding this specimen that Bradley found is really good in terms of zeroing in on the actual age of the Belgrade lower Miocene deposits from the quarry. So now, if you don't know about how to get involved in the myFOSSIL project, it's still continuing, and we have an app. You can download the app, you can join groups, and you can communicate and talk about your finds, take pictures of them and upload them and share them with other people that you've identified as members of your group using the myFOSSIL app. And you also, I'm not an app person, I don't use my iPhone very much, but I go online to the web, and there are 69 different groups on the myFOSSIL website that all have specific interests. For example, there's one called Astonishing Arthropods. That's not for me, but maybe for you. It looks like they're trilobites, and there are 186 members of that. So there are thousands of people who communicate with one another and share their interests in paleontology using the myFOSSIL groups section of our website. And in fact, I made sure the bottom there is Belgrade Mine. There are 101 members on the myFOSSIL project. And there doesn't cost anything to join. You just have to sign up. And then you can start talking to other people about your interest in Belgrade fossils. The other thing that's really cool is if you send us some of your fossil specimens, and they're of research grade, meaning we know where they're from, specifically within the stratigraphic unit, we will post them as part of the myFOSSIL e-museum. This is basically a public museum of specimens that have been collected by amateurs that are not in the Smithsonian, they're not in the Florida Museum of Natural History. They're digital images and specimen records that are in the myFOSSIL e-museum. It's an online virtual museum. Okay, so you send us photographs and tell us what the data are, where you found them, and then they can be classified as what's called research grade. And then those particular, all the research grade fossils are aggregated. And okay, I got ahead of myself, but once you upload your fossils, they're curated by a team of expert volunteers. And if any of you want to become a volunteer, you can. And if there's sufficient research potential in the curated specimens, they can be classified as research grades, which include the specimen, the locality records, and the images, but not the fossils themselves, the way Jeanette said. Then these become what are called digital voucher specimens. Once you get a digital voucher of research quality, then we are going to send these in batches to these international databases so that scientists can use them for research. And some of these databases like iDigBio have 125 million specimen records, and then GBIF has 1.5 billion specimen records. So you could be part of by your fossil collecting, you could be part of something big. For example, Diane, your Paratosaurus, once we get it where it needs to be and get it cataloged on this in the myFOSSIL e-museum, we will port it over to iDigBio and GBIF with your name as the collector, and you will be part of you will be recognized for that donation in these international what are called big biodiversity databases. And this is the wave of the future in terms of paleontology and the kind of science that we do. So to get back to wrap up here, I'm really interested in early Miocene life throughout North America, going from the eastern United States to the northwestern Nebraska and down into Panama. And I'm interested in helping us better understand what life was like in the early Miocene in eastern North America. And the Belgrade fossils are really important for us to understand what life was like in North Carolina and how things have changed since 20 million years ago. All right, so that concludes our presentation, and this is good because we have about 15 minutes or so for questions or comments. And I'm going to let Victor, I'm going to mute my microphone. I'm going to let Victor moderate the Q&A.
Sure. So we didn't get a whole lot of questions, but Emily Simpson did ask, can you use student volunteers? I think this is in reference to myFOSSIL. Jeanette did respond, but I'd like everyone to know this, that yes, we can absolutely use student volunteers on the myFOSSIL project.
We also have amateur paleontologists from other fossil clubs who are specific, who they're appointed for a period of time as curatorial associates of the myFOSSIL project. And if you have a specific interest, like in Paleozoic brachiopods or whatever, and we need expertise, then we would be interested in you volunteering. And basically, you spend a couple hours a week sorting through the incoming fossils that might be Paleozoic invertebrates, and then you identify which ones might be of research grade, and then you let the head curator know of the collection, and then we can categorize those in the e-museum.
Awesome. So our next question is from Debbie Palmer. She asked, is there a library to see all Miocene age fossils found at Belgrade for us to reference?
Not yet. It's sort of here, there, and it's in several different, there's not a single place that you can go. There's not a single atlas that you could go to try to identify all of the early Miocene land mammals from Belgrade. We will, within the next couple of years, we will develop a scientific publication and talk about digital vouchers, and then present descriptions of the fossils that have been uploaded to the museum. But to answer your question, not yet.
Okay. This is a comment rather than a question. Once we're doing loans again, we would be happy for you to scan the Belgrade Daeodon incisor in our NCSM collections. So there is another Daeodon fossil, it sounds like, in another collection that they would love to have scanned.
Yeah, that's great. And actually, if that's Chris.
Yes.
Yeah. Hi, Chris. Thank you. Yeah, I let the ball drop on that a couple of years ago. We're getting back to this project again. And actually, I'd hoped to come and visit your collections tomorrow because I was planning to do a physical visit to your museum, to the club today. And then I was going to get in touch with you a couple months ago and say, hey, can I come and look at your collections tomorrow and see what you have? So thank you very much. We need to reinitiate that communication. That would be really good. Thanks.
Yeah, we'll be happy to have you once we're reopen.
Thanks, Chris. Thanks very much.
All right, so we have another question from Debbie Palmer. Once the myFOSSIL e-museum is populated, how soon can public view the specimens?
Immediately.
So if you don't mind, may I add to that?
Well, yes and no. I mean, sometimes you can keep it, Victor. It's how you choose to grant permission for use. Victor, it's more nuanced, but basically, our philosophy is once those photographs are in that museum, they should be in the public domain for people to enjoy and scientists to potentially study. But Victor, go ahead and elaborate on that.
Yep, so Bruce alluded to this, but basically when you upload a fossil to myFOSSIL, you have the option to make that public or private. So it's really your choice if you want to make that fossil accessible to anyone else, or you can simply use myFOSSIL as a curation tool for yourself. It's really up to you. But if you do make it public, as soon as you've uploaded it, anyone can see it. If it is private, only the admins on the website can see it and yourself. And it will not be sent off to GBIF or iDigBio if you have it listed as private.
Right, and the other cool thing is you can comment. So maybe one of your club members has uploaded a group of fossils, pictures, and you go in and take a look, and you have some ideas and say, well, you want to talk about them. Then there's an opportunity. There's a chat function where you can, not chat. There's a commenting function for fossils that other folks have uploaded. So it's a means of communication about the fossils, and the group is a means of sort of social, we call it social paleontology, where you can actually talk to other people, not just from your club, but from other clubs. I'm a member of about a half dozen or 10 clubs. Victor, I don't know how many different groups, not clubs, groups. Each of us are members of different groups, and that's a good way for us to communicate.
Victor, can you elaborate on the GPS function as well, please?
Yeah, so most people, when they choose to upload as private, it's because they don't want to give out the locality information for their fossil. So if you choose, you can also choose whether or not you want to disclose the location. You can make it public and choose to not disclose location if you want to do it that route. So there's different avenues you can take to basically provide as much information as you wish to provide about that fossil. We're not forcing you to detail every aspect of it if you don't want to. This is another great question. So for the more common fossils from Belgrade, hold on, not so much a question as a comment. For the more common fossils from Belgrade, I'm sure the NCFC books are the place to go for images.
They are, absolutely. Yeah. And they're also, they're wonderful images, and there are also some images of the rarer taxa like the Daeodon. So it's not just the more common fossils. That's where I go. I mean, it's a great place to look for the fossils.
But I will add, we're not only interested in rare things. If you find things that are common, we still want those to be uploaded to myFOSSIL as well. Because, if anyone goes to that site and is using myFOSSIL as a resource to help them understand something about a site or identification, uploading common things is still important for others.
And just to address Debbie's last question regarding if researchers can see the image when it's private, no. So only the admin of myFOSSIL can see your image. It's once you make it public, but researchers can then reach out to you and ask you about it, and then you can have conversations with them about where your fossil was collected and so on.
Any more questions from anyone?
Bruce, do you want to ask people if they've brought any specimens to show?
Sure. If you think, now, I don't know if we can zoom in on them.
Well,
Oh my gosh.
All right, so you should be able to make, right now I'm looking at gallery view, but if you look in the top right
Yeah,
corner,
of course. That's right, speaker view.
or you can go in the top right corner of any individual's image, and you should be able to pin their video so that you're only seeing them.
Okay,
So,
now, yeah, good. Now, Victor, I'm going to need your help with IDs, but
Sure.
we have, so Diane, you'd like to, our presentation will go an hour. We have about 7 minutes longer. I just want to,
you're doing fine. Just go as long as you want.
I know, but you guys have a business meeting to conduct, so I was planning to go for an hour, so we have about 5 to 10 minutes, let's say, and then we'll wrap up. Is that okay with you?
That's fine.
Okay, so
I'm going to write down whoever's holding up fossils. I'm going to write down your name real quick so that we can go in order and you don't have to hold them up forever. So if you have fossils you'd like for us to see, please hold them up to the video real quick. I have Debbie, Tayden, Ramona.
Oh my gosh, that's really cool. So rotate that around.
If you don't have your video on and you have fossils,
Yeah.
please turn on your video so I can.
Let me go into speaker view. Hold on. So Tayden.
Thanks, Ramona. I do have yours.
Actually, it's Terry.
Terry,
Oh, Terry,
okay, I'm sorry.
That's all right. I don't know why my name looks like that compared to everybody else's.
Okay, so it's a little fuzzy for me, but I'm pretty sure I know what it is. If you could rotate that around. Yeah, so that's from Belgrade?
Yes.
Yeah, so that's from the upper, remember I said that there's some Pleistocene deposits above the Pliocene? That looks like a fossil horse tooth and equus.
That's what I assumed it was too.
Yes, that's cool. The Pleistocene, of course, I love, horses are near and dear to my heart. I don't care how big or small they are, where they come from. So that's really cool. That's a tooth of an equus from the Pleistocene overburden at the top of this sedimentary sequence at Belgrade. Very nice.
Yeah, and this is from probably 10 years ago when I was there. So
you know what you could do is if you would take a picture of that now, that you should put scale bars next to the picture and upload it. I just want to have it on record that there are photographs of fossil horses from the Pleistocene in Belgrade. That'd be great.
Okay.
And yeah, good.
And did you ID Debbie's?
No.
Okay, Debbie, if you could hold yours up, please.
Can you see it? This is a turtle.
Yeah.
It's 10.5 inches long. It's
Can you
complete.
flip it over?
Yeah, it was found in 2016 and far back of a quarry. It was a section that was opened up later in the day.
Yeah, that looks like one of the costals.
Yeah. So the way that we identify these, so you're looking at the underside, you're showing us the underside, now you're showing us profile. This side, so this is the outside of the shell. The texture on that is what we would use to identify this, but on my screen, it's too blurry for me to be able to identify it from here. Looks much larger than any of the turtles we've found from the 5 mounds. So I'm wondering if it's from a different age. But yeah, it definitely looks really interesting.
Is there, are there tortoises there, Bruce?
I don't know, but I was also thinking, given the thickness of the shell, could that potentially be a tortoise? It's really thick. Yeah.
It's 1/2 inch thick.
Yeah, and it might be from one of the other localities. It would have to be from probably the Pliocene. It could be from that Miocene locality, but it's hard to say. Because tortoises.
Is that the end of the rib by your left?
Yeah, it is.
Yeah.
Yeah, but it's certainly the most complete specimen of a turtle-like animal that I've ever seen from Belgrade. That's a nice specimen, Debbie. Likewise, you should upload that, and with all the uploading should have a scale bar and their instructions about how you should upload fossils from myFOSSIL into the museum.
And I would say the texture on the front looked very tortoise-like.
Yeah, it does. Yeah.
From some of the stuff we have.
Yeah, I would. That's the inclination. I would want to first compare it with a tortoise and see whether there's a good match. I agree.
Okay, cool.
And then Ramona, you have a delicate looking little bone. Let me see if I can find you real quick. All right. I'm gonna unmute you, so if you want to talk about it.
A little too high.
All right, you are unmuted, Ramona, so if you want to
I'm
Thank-
not very skilled at this.
pull it back a little bit.
Yeah, and it doesn't float, which is the only kind of test
It looks like turtle,
Yeah, it looks like a tiny turtle bone.
like a limb bone,
Yes.
maybe a femur.
Yeah. Yeah, yeah.
Yeah, no, that's beautiful too.
Again,
Alright.
all these things we didn't know about, obviously, because you've had them. And if you wanted to take pictures, you can make simple pictures of them. Make sure you have a scale bar and it's in focus, and then just simply upload it to the museum, and then it'll be placed in the public domain for other people to say, oh, I didn't know that there was a tortoise like that from Belgrade, and then we would know that there's actually those fossils in existence. So Jeanette, does that conclude our ID?
I think so, unless somebody else that I missed has a fossil. Share that in the chat if you do. If not, I think that's everyone, Bruce.
Great. So we're right on time. I like to be mindful of people's time. We're just at an hour. So Diane, I believe this concludes our presentation. Thank you very much for this opportunity. Thanks to Victor and Jeanette for your Dr. Perez and Jeanette for your excellent presentations as well. I hope you all understand why Belgrade is important, not just to you, but also to us in terms of science, and anything that you could do in the future to help us with the early Miocene part of the section. I would love to know about it, and to the extent that we could collaborate, I'd be interested in doing that. So thanks again. Thanks to Julie and Diane and Lee. I'm just looking, and Linda for your past contributions, and I look forward to working with as many of you as possible in the future. So thank you very much, Diane.
Thank you, Bruce, and thank you, Victor and Jeanette. We thank you not only for your presentation, but for the tech help and for lending us your Zoom platform. Thank you very much. Everybody can clap.
All right, very good.
Great. So, Linda.